Hello students, welcome to our physics practical class. This is physics practical class part 2. In the previous class, we learned about construction and working of meter bridge experiment. Construction and working of meter bridge experiment. In this class, I am going to discuss about the first experiment in second PU. This is experiment number 1. The aim of the experiment, that is determination of resistance of a given wire using meter bridge, and hence to find the resistivity of the material of the wire. Determination of resistance of a given wire using meter bridge, and hence to find the resistivity of the material of the wire. So this is the circuit diagram. So actually, what is the meaning of meter bridge? Meter bridge is a practical form of Wheatstone's network. So what is the meaning of Wheatstone's network? So Wheatstone's network is an arrangement of four resistances in the form of quadrilateral, used for measuring one unknown resistance in terms of three known resistances, right? So meter bridge consisting of three thick metallic strips. Those are arranged on a wooden board to form two gaps, left gap and right gap. A wire of unknown resistance that is connected across the left gap. Standard resistance box is connected across the right gap of a meter bridge. Okay, actually, so here this is point A. This one is the point C. This is point B. This is point D. So a cell and plug key is connected across A and C. A galvanometer and sliding contact is connected between B and D. Okay. So a uniform wire AC of 1 meter length is stretched. A meter scale is fixed below the wire. A standard resistance box is connected across the right gap. A wire of unknown resistance is connected across the left gap. Actually, this is the construction of this experiment. So the working is very simple. When the jockey is connected at point A, jockey is pressed at one end, that is at point A. So galvanometer shows a momentary deflection in one side, and after that jockey is connected at the point C, the other end, right end of the meter bridge. So what happens? Again, galvanometer shows a momentary deflection, but in opposite direction. Okay, so that is the working. So in this experiment, there are two very important observations. Number one, radius of experimental wire, actually that is given. That value is 0.195 into 10 power minus 3 meter. And the second observation, that is the length of the experimental wire, that is also given. So the length of this experimental wire, the length of the experimental wire is 0.5 meter. Length of the experimental wire is 0.5 meter. And this is the tabular column. So now let us start the experiment. So first, close the key in plug. So now the current drawn from the positive terminal of the battery, and that is flowing through the bridge wire. Okay, so the jockey is gradually moved on the bridge wire until the galvanometer shows null deflection. So first, a suitable resistance, that is unplugged from the resistance box. This is the standard resistance box. A suitable resistance that is introduced in the standard resistance box. So this is trial number one. So in the first trial, for example, 1 ohm, 1 ohm, this is in terms of ohm. 1 ohm is introduced in the standard resistance box. Okay, so if the jockey is gradually moved on the bridge wire until the galvanometer shows null deflection, so D is the balancing point, the corresponding length AD, that is balancing length. Okay, so in this case, in the first trial, the balancing length is 30 centimeter. So this is 30 centimeter. So 100 minus 30 centimeter is how much? 100 minus 30 centimeter, that is 70. Okay, so this is about the first trial in this experiment. And so let us go to the next trial, that is trial number 2. So in this trial, first, a suitable resistance that is introduced from the standard resistance box. So for example, 2 ohm is introduced in the standard resistance box. So after that, the jockey is gradually moved on the bridge wire, meter bridge wire, until the galvanometer shows null deflection. So in this case, we will get the balancing length, that is 17.5 centimeter. 17.5 centimeter. Okay. So after that, go to the next trial, trial number 3. So now a suitable resistance again introduced in the standard resistance box. For example, that is 3 ohm. Okay. Next, the procedure is same. The jockey is gradually moved on the bridge wire until the galvanometer shows null deflection. When the key is closed and suitable resistance is unplugged from the standard resistance box, so after that, jockey is gradually moved on the meter bridge wire until we will get null deflection in the galvanometer. So in this case, the balancing length is 12.5 centimeter. So let us go to the first trial calculations. Trial number 1. So in the first trial, what is the value of S? S is equal to 1 ohm, and L, the balancing length L is equal to 30 centimeter. 100 minus L value, this is 70 centimeter. Okay, what is the formula? So unknown resistance that can be calculated by using the formula R is equal to SL divided by 100 minus L. So here, what is the value of S? S value is 1 and L value is 30. 100 minus L, that is 70. So 30 divided by 70, so the value is 0.42857. 0.42857. So root of 57 and we get 6. 0.4286. What is the unit? Ohm. This is about the first trial calculation, and go to the next trial, trial number 2. Trial number 2. So in the second trial, so what is the value of S? S value is 2 ohm, and L value, what is the value of L? L value is 17.5. L value is 17.5 centimeter. 100 minus L. 100 minus 17.5 is 82.5 centimeter. This is 82.5. Okay. So the formula is same. R is equal to SL divided by 100 minus L. So your S value is 2, L value is 17.5 divided by 82.5. Okay. So 2 into 17.5. So that is 35 divided by 82.5. So finally we get value that is 0.4242. 0.4242. Next, go to the next trial. Trial number 3. Okay. So in the third trial, what is the value of S? S value is 3 ohm. L value is 12.5 centimeter. 100 minus L. 100 minus 12.5 is 87.5 centimeter. So R is equal to S value 3, L value 12.5 divided by 87.5. So 3 into 12.5 divided by 87.5. So you get here 0.42857. 0.42 approximately 0.4286. 0.4286 ohm. Okay. So in the second trial, 100 minus 70 is 82.5. So in the third trial, 100 minus L is 87.5. So in the first trial, what is the value for? That is 0.424286. 4286. The second trial, R value 0.4242. The third trial, R value 0.4286. After that, we have to calculate the mean or value. So that is 0.4286 plus 0.4242 plus 0.4286 divided by 3. So we will get 0.42713. So the mean or value is 0.42. 0.42713. 0.42713. Okay. After that, we have to calculate the resistivity. So, what is the expression for resistivity? Actually, R is equal to rho L divided by A. Rho is equal to RA divided by L. So, area of the Y is pi R square divided by L. So, here L means that is the length of the experimental wire. Okay. So, rho is equal to R is 0.42713. 0.42713 into pi is 3.14. So into radius, that is 0.195. 0.195 into 10 power minus 3 whole square. Okay. So 4 divided by length of the experimental wire, that is 0.5. 0.5. Rho is equal to 0.42713 into 3.14 into 0.195 into 0.195. Okay, that is 0.05099 into 10 power minus 3 whole square, that is 10 power minus 6, all divided by 0.5. Okay, 0.5. So finally, we will get 0.1019 into 10 power minus 6. So 0.1019 10 power minus 6 is micro. What is the unit? Ohm meter. So the resistivity of the material of the wire is 0.1019 micro ohm meter. Okay, so after that, let us discuss about some very important Viva questions regarding this experiment. So the first question is, Define the resistivity. So what is the meaning of resistivity? Okay, resistivity of the material of the wire. So resistivity of the material of the wire means resistivity actually that is numerically equal to resistance of unit cube of a substance or the resistance of the wire having unit length and unit area. So resistance of the wire having unit length and unit area. That is the meaning of resistivity. Okay, resistivity of the material of the wire. So what is the SI unit of the resistivity? SI unit of resistivity is ohm meter. So on what factors does resistivity of the given material depends? So this is also a very important question. On what factors does resistivity of the given material depends? Actually, resistivity depends on the nature of material. It depends on the nature of material, chemical composition, and temperature. Resistivity depends on nature of material, chemical composition, and temperature. It does not depend on the length and area, but resistance depends on resistance of the wire. How does the resistance of the wire depends on length? So resistance actually directly proportional to length, so inversely proportional to area. But resistivity does not depends. Resistivity does not depends on the length and area. So does the resistivity depend on length and area of cross section of the material? No. Resistivity does not depend on length and area. It is independent of length and area, but depends on nature of material, chemical composition, and temperature. Suppose if the length of the conductor is doubled, length of the wire is doubled, what will be its new resistivity? The new resistivity that will remain same. Why? Because the resistivity is independent of the length and area of cross section. Okay, the length of the wire is doubled. So what happens to the resistivity? Resistivity will remain constant because the resistivity does not depend on the length. So the next question, what is the principle behind the working of meter bridge? So meter bridge actually works on the principle of Wheatstone's bridge, Wheatstone's network. So what is the meaning of Wheatstone's network? Wheatstone's network is an arrangement of four resistances used for measuring one unknown resistance in terms of three known resistances. Wheatstone's network is an arrangement of four resistances in the form of quadrilateral used for measuring one unknown resistance in terms of three known resistances. Okay, what is meant by balancing length in a meter bridge? So this is also very important question. What is meant by balancing length in a meter bridge? It is the length of the meter bridge wire from point A point A to point D. Okay, point A to the balancing point. Actually, your AD is L, DC is 100 minus L. So A to D is L. So D to C value is 100 minus L. Okay. So what is the meaning of balancing length? It is the length of the meter bridge wire from point A to the balancing point. Okay. So that is actually the balancing length. So what is the null point or balancing point? The position of the sliding contact on the meter bridge wire at which the galvanometer shows zero deflection. Okay, the position of the sliding contact. So this is the position of sliding contact on the meter bridge wire at which galvanometer shows zero deflection. So that particular point D is called balancing point. So the corresponding length from A. So this is the balancing length. AD is the balancing length. D is the null point. What is the meaning of null point? The position of the sliding contact on the meter bridge wire at which the galvanometer shows zero deflection. So in a balanced Wheatstone's network, what amount of current flowing through the galvanometer? Zero. Current flowing through the galvanometer is zero. So in a balanced Wheatstone's network, suppose a galvanometer is replaced by a capacitor, what happens to the balancing condition? That will remain constant. In a balanced Wheatstone's network, galvanometer is replaced by capacitor. What happens to the balancing condition? That will remain constant. In a balanced Wheatstone's network, galvanometer and cell are interchanged. What happens to the balancing condition? That will remain constant. What is the meaning of cell? A cell is a device which provides the necessary potential difference to maintain the continuous flow of current in the circuit. What is the function of plug key? Plug key switches on or switches off the circuit, making or breaking the circuit. What is the meaning of galvanometer? Galvanometer is a sensitive ammeter. It is a device used for measuring very small currents, that is of order 10 power minus 6 ampere to 10 power minus 9 ampere. What is the principle behind the working of galvanometer? So when a current carrying coil is placed in the presence of uniform magnetic field, it will experience torque. That is the principle behind the working of galvanometer. So why meter bridge is preferred to measure the resistance? Why meter bridge is preferred to measure the resistance? This method is not affected by EMF and internal resistance. This method is not affected by EMF and internal resistance of the cell. That is why meter bridge is preferred to measure the unknown resistance. So the next question, balancing length as measured, balancing length as measured from left side in a meter bridge is more than 50 centimeter if R and S are resistances in the left and right gaps respectively, then which resistance is greater? So this is quite a complex question, but it is very simple. Balancing length as measured from left side in a meter bridge is more than 50 centimeter. That means the value of balancing length is more than 50 centimeter. Okay, so R and S or resistances in left and right gap. Which one is greater? So what is the balancing condition? Balancing condition is P by Q, that is L divided by 100 minus L is equal to R divided by S. So resistance is directly proportional to L. So S is directly proportional to 100 minus L. S is proportional to 100 minus L. R is proportional to L, S is proportional to 100 minus L. Actually, here L is more than 50, means S is less than 50. Is it not? Suppose L is equal to 60 centimeter. What is the value of 100 minus L? 100 minus L, that is 60 minus 100 minus 60, that is 40. Okay, suppose if L is equal to 60 centimeter, 100 minus 60, so this value is 40. So which one is greater or is greater? Is it not? Because or is directly proportional to L. So if L is maximum, then resistance or also becomes maximum. Okay, go to the next very important question. While performing the experiment, after completing two trials, while performing the experiment, after completing two trials, the galvanometer is changed and two more trials were performed. Is the resistance obtained in the last two trials different from the first two? Why? Actually, here resistance will remains constant. Okay, why? Because in a balanced Wheatstone's network, the galvanometer is replaced by another different resistance galvanometer. The balancing condition remains constant. That means resistance does not change. Okay. What is the question? While performing the experiment, after completing two trials, the galvanometer is changed and two more trials were performed. Is the resistance obtained in last two trials different from the first two? What is the answer? No. Why? Because balancing condition does not change with galvanometer resistance. So what is the SI unit of resistivity? SI unit of resistivity is ohm meter. So the noun resistance in the right gap of meter bridge. Noun resistance in the right gap of meter bridge is kept 0. The noun resistance in the right gap of meter bridge is kept 0. 0. What will be the deflection? So this is also a very important question. Actually, in this case, galvanometer does not show any deflection. Okay, the noun resistance in the right gap of meter bridge is kept 0 ohm. So what will be the deflection in the galvanometer? There is no deflection. Galvanometer does not show any deflection. Okay. So resistance in the right gap of a meter bridge is increased. What happens to the balancing length? Resistance in the right gap of a meter bridge is increased. What happens to the balancing length? The balancing length increases, right? Balancing length increases. Thick metal plates are used in a meter bridge for connections. Why? Thick metallic strips, thick metal strips are used in meter bridge because thick metal plates do not contribute any resistance to the meter bridge wire. Thick metal plates do not contribute any resistance to the meter bridge wire. So these are all very important Viva questions. Okay, thank you.